Okay. So we'll get started with the quiz. Give us some files we need to use. Download those real quick. Okay. So question 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. A simple random sample is drawn from each population. X bar is normally distributed for each group. Mu is greater than 0, and the sample size must be the same for each group.
Sorry, give me 1 second. My eyeline's being moved.
Okay.
The sample size must be the same for each group. X bar must also be normally distributed. And I'm pretty sure, well, with independent samples, then the sample must be, a random sample must be drawn from each population.
Okay. So the only one it's not is mu is greater than 0.
Yeah. Because the only time that because we learned that like dependent and independent samples, it talks about how like if you're getting the height of son compared to their fathers, then you take a random sample of sons and then compare their fathers to it. So
Right.
if it's 2 independent samples, then they both have to be random, and then everything else is the same as everything that we've been learning.
Yeah. Okay. Question 4. The test statistic for a hypothesis test comprising two means with independent samples is a z-score, t-score, or F statistic. T-score?
T-score, yeah.
Two samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2. Knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2. It's the second one.
Okay. Okay. So for the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let mu1 be the mean bill at the Idaho Falls office, and let mu2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis. Mu1 equals mu2, and alternative hypothesis mu1 is less than mu2. And use level significance of alpha equals 0.1. Yes. Idaho Falls is first one. Okay, so question 6 is what is the degrees of freedom rounded 3 decimal places? So I'm getting 37.996.
Okay. 1 second. This one is the 2-sample t-test, right?
Yeah.
Okay.
So question 7.
Okay.
What's standard deviation for Rexburg? Yeah, okay.
Wait. For question 6, the degrees of freedom, what did you get?
37.
37.9996.
Was there anything else after that?
I didn't. It rounded to 3 for me. So.
So 37.3?
37.996.
Oh, yeah, that's, yep. I have to. Okay. Right. Yeah, go ahead, Dimitri, with question 7.
Okay. Okay, question 7. What is the sample? It is 0.875.
Yeah. 208.875.
For Rexburg,
Yeah, that was the first.
the first set should be Idaho Falls.
Okay.
Oh,
Yeah, and it's
no, the second is Rexburg.
Yeah,
Yeah?
the second one is Rexburg.
The second, okay. 206.637.
Mhm.
Great. So question 8 is, what is the test statistic? And I got negative 0.434.
Same.
Yeah.
What is the p-value? I have 0.667.
Did you change the test type to less than?
Oh, I had it as greater than. So then I have 0.333.
That's what I got.
All right, what is the correct decision based on it is greater than the level of confidence or the alpha, they'll fail to reject the null hypothesis.
Yeah.
Okay. Question 11. Suppose instead that you would use the alternative hypothesis as sample mean 1 is not equal to sample mean 2. What is the correct decision based on this evidence? We have sufficient evidence that the mean distance fields between the two cities are different. We have insufficient evidence that the mean distance fields between the two cities are different. And then we have sufficient or insufficient evidence that the two cities are the same. So, we have we have sufficient evidence that the mean dentist bills are the same, right? Or is it insufficient evidence that they're different?
So yeah, we're rejecting the alternative hypothesis because our thing always references back to the alternative hypothesis. So we have insufficient evidence that the mean dentist bills between the two cities are different.
Oh, perfect. Okay. Thank you.
Okay. So for the next 6 questions, use the data file freshman dinner. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let mu1 represent the mean number of times in a month that a student from Colorado cooks dinner, and let mu2 represent the mean for Utah students. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is mu1 equals mu2. The level of significance is alpha equals 0.05. What is the appropriate alternative hypothesis? It is mu1 does not equal mu2.
Yep.
Let me pull the data file up.
Now, if you pull the file up, I don't know if this is on everyone's, but there's a different number
Yeah.
in Utah from Colorado. So,
Yeah, there's 2 more.
I don't know if that's going to affect it.
I think it.
Okay. Level of confidence was 95%?
Yeah.
Okay. So, what is the test statistic? I have 0.845.
Yeah, that's what I got. I got negative 0.845.
What did you put in as the type of test?
Not equal to. My confidence interval is different. Put the Colorado column and column in variable 1. And put the Utah column in variable 2.
Oh.
Which is opposite from what is in the Excel spreadsheet.
Is that what I asked us to do?
Let mu1 represent the mean number of times a month that a student from Colorado cooks dinner. Oh, I think so.
Okay. I got the same thing.
So what is the question? Sorry. Yeah, what is the answer? Repeat please.
Negative 0.845.
Okay. We shouldn't delete the numbers from
I don't think so.
Okay.
I mean, if we're wrong, then we can try something else.
Yeah. They don't be the pairs.
Right.
Yeah.
Did we already do the p-value? Sorry,
No, not yet.
Okay. For the p-value, I have 0.411.
Same.
And the decision we make is still fail to reject because 0.411 is greater than the. for sample 1 minus sample 2, an estimate for the difference between sample mean 1 and sample mean 2. Input your answers below. So we're going back to the paired sample test, right? Because it's asking for a difference. Wait, so how are we doing? Is this looking in the reading? Says you just find the difference of the population mean of both groups. So the mean for variable 1 is 15.2. The mean for variable 2 is 16.667.
Uh-huh.
I'm not sure if the differences subtracts them exactly because it's all rounded, but do we then input the mean up in the mean section of the summary statistics and see what happens?
So in the two sample t-test, it gives us the upper and lower bounds of the confidence interval.
Hmm.
So what I'm not sure of is how we figure out the margin of error.
Usually what I've always done for the margin of error is find the difference between the two and divide it by
Divided by
2.
2. Yeah.
Yeah, which is an easy way to do it in Excel. Not sure if it's necessarily correct. And I feel like when I was watching the videos, I don't remember the margin of error. But they gave equation that they said wasn't in the reading.
Oh yeah.
I don't know if
Yeah,
you saw
I didn't
that.
watch the videos today because I ran out of time.
The margin of error that I have is 3.681.
Yeah, that's what I got by computing the difference of the upper
Yeah.
and lower bound.
And that's always worked for me, so I don't know why it wouldn't work this time. But and then the lower bound was 5.147, and the upper bound was 2.24 or 214.
Yeah, negative 5.1%.
Yeah. So do we just want to try that and submit it?
Yeah. Well, those were right, but I got something else wrong.
We got 0.5 on the.
Yeah, question 3.
I guess the sample size doesn't have to be the same because the last one we did, the sample
Right,
size
it wasn't the same.
Yeah.
It still worked. Okay.
Awesome.
Well, do we have any questions?
Nope.
Yeah, I'm pretty good. I think I'm going to go rewatch the videos just to make sure.
Yeah, they're good because he does a nice description of the differences between the last 3 lessons we just had. So like when we used the first one with just a 1 sample t-test, and then the difference between a paired sample t-test and then a 2 sample t-test. So that was,
Yeah.
I liked watching them just because he did a good job of explaining that.
All right.
Okay. See you guys next week.
Yep.
Alright, bye-bye.
Thank you.
Yep.